The population mean is one of the most commonly used measures of central location. To compute the arithmetic mean of a data set, at least an interval scale is required. All values in the data set are used in its computation. A unique value, the mean, is computed by adding all the values in the data set, then dividing by the resulting sum of the number of observations. In the next slides, we will distinguish the population mean from the sample mean. Both are computed in the same manner. The population mean is one of the most commonly used measures of central location. The population mean, denoted by the Greek letter mu, is computed by adding all, this is a key word, all values in the population and dividing that by the total number of population values. Here's an example of population mean. There are 42 exits on I-75 through the state of Kentucky. Listed below are the distances between exits in miles. Why is this information a population? This is a population because we are considering all of the exits on I-75 in the state of Kentucky, not just some of them, all of them. And then to find the mean number of miles between exits, we're going to use our equation mu equals the sum of x divided by n. So if we go back to this slide here, n is the number of the values in the population. Mu represents our population mean. The sum of x is the sum of the x values in the population. So if we go back here, we are going to add up all of these numbers here. And then we are going to divide it by the total number, which is 42 exits. And we get our final answer. What is the mean number of miles between exits is 4.57. The sample mean, denoted by x bar, is one of the most commonly used measures of central location for sample data. Several slides ago, we defined the population mean, denoted by the Greek letter mu, and we showed how it is computed. So the computation of the sample mean is the same process. So we're going to add all the values in the sample data and divide by the total number of the sample values. Here is an example. So, Suncom is studying the number of minutes used monthly by clients in a particular cell phone rate plan. A random sample of 12 clients showed the following number of minutes used last month. So that's right here. What is the arithmetic mean number of minutes used? So we are going to go ahead, use the equation that they gave us on the previous slide, and we are going to add up all the values in the sample. That goes in our numerator, right there, our top value. Divide it by the total number of values in the sample, which is 12. And the arithmetic mean number of minutes used is 97.5 minutes. The major properties of the arithmetic mean include the following. Every set of interval level and ratio level data has a mean. We recall from Chapter 1 that interval and ratio level data are those that are typically measured. Examples are variables such as ages, income, weights, volumes, and temperature. 2, all the values are included in computing the mean. 3, the mean is unique. That is, there's only one mean in a set of data. 4, the sum of the deviations of each value from the mean is 0. While the mean is one of the most commonly used measures of central location, it has a weakness. Because all the values in the data set are used in its computation, if one or two of these values are extremely large, particularly to only one side of the distribution, the mean will be pulled towards that end. In other words, the mean will be skewed and therefore might not be an appropriate average to represent the data. For example, say that a population has 4 members with values of 2, 3, 5, and 25. The average of this population is 7.5, which is skewed to the high end because we have that one large number, 25, that is really pulling our average up.